Section 1.4, Rewriting Formulas and Equations. So first of all, let's define what a formula is. A formula is an equation that relates two or more quantities, usually represented by variables. So some common formulas would be area equals length times width, or the Fahrenheit to Celsius would be a formula. And what we're going to be doing is solving for a variable. So this just means to rewrite an equation as an equivalent equation in which one of the variables is on one side of the equation and that same variable does not appear on the other side of the equal sign. So let's start with something fairly simple. D equals RT. We're going to solve this for t. Well, this is the distance formula. This just means distance equals rate times time. And we're multiplying time by the rate, which means to undo that and to solve for t, we need to divide both sides by the r. So r divided by r is 1, so we're simply left with t on the right equals d divided by r. The next formula, you perhaps recognize this as the area of a trapezoid. So we have the area equals 1/2 the sum of the bases times the height. We want to solve this for B2. So we'll notice that we're multiplying with the parentheses by h, so we need to undo that multiplication by dividing both sides by h. And again, the h's cancel out on the right, so we're left with a over h equals 1/2 times the base 1 plus base 2. Now we're multiplying by 1/2, and we could certainly divide by 1/2, but that would give us an improper fraction on the left. We don't like to have fractions within fractions. So instead of dividing by 2, we can multiply by 1/2 by 2. So we're going to multiply both sides by 2. 1/2 times 2 on the right gives us 1. So then on the left, we're going to be left with 2 times a divided by h equals base 1 plus base 2. And then finally, we're just going to subtract that base 1, so we get that 2a divided by h minus base 1 equals base 2. And again, we maintained that equality. We did to one side what we did to the other. I just didn't show in that last step that we subtracted base 1 from both sides. Most of the problems are going to be like this that we're going to be dealing with in this section. We're going to solve for y. So if you notice, we rewrote the equation. We have 5x plus 3, and I circled the y because that's what we're solving for. So we need to undo what's being done to that y. So we're going to undo in the opposite order that we would do them if we substituted something in. So the first thing we need to undo is subtracting 5 from both sides, 5x. And if we simply look at column subtraction, column addition, we're left with 3y on the left equals negative 5x plus 8. And now we have 3 times y, so we need to divide both sides by 3. And we're going to end up with y equals negative 5/3 x plus 8/3, because we can divide that 3 into both those terms. We might be asked to find y when x equals negative 5, in which case we would plug negative 5 in for the x and simplify the function. And you might say, well, why can't we just do that to the original problem? And you could. Sorry, let me go back. You would usually solve for y in this case more if we wanted to fill out a t-chart, so we had a long string of values for x. Let's try another one of those. So again, we're solving for y. We're going to subtract 3x from both sides. So then again, using column addition, we would end up with 2y equals negative 3x plus 12. And again, 2 times y means we have to divide both sides by the 2. Dividing both those terms, we end up with y equals negative 3/2 x plus 6. This one's a little bit trickier because if you'll notice, both those terms have a y in them. And so we can't just subtract one of those terms to the other. We need to have just one single y on the left-hand side. So what you need to think about is the distributive property backwards. It's called factoring, so we're going to pull out that y. And if you notice, if we multiplied, use the distributive property in, we would end up from the second step back to what we have in the first step. Now to solve for y, we're multiplying y by that parentheses, so we can just divide both sides by what's in the parentheses. And we end up with y equals 8 over 2x minus 5. Let's try another one of those. You might want to pause the video and try this on your own. But our first step is to use the distributive property backwards. So we're going to pull that y out of both terms. Again, notice if I multiplied it back in, I would have what I started with. And then we're going to divide both sides by 4 minus x. And finally, a campus bookstore sells t-shirts for $15 each and sweatshirts for $22 each. Write an equation for the bookstore's revenue R from selling T number of t-shirts and S number of sweatshirts. So remember that revenue simply means the price times the number. So we have the price per t-shirt times the number of t-shirts plus the price per sweatshirt times the number of sweatshirts. Substituting in everything we know, R is the revenue. Price per t-shirt is $15. The number of t-shirts is T, plus 22 is the price per sweatshirt times S number of sweatshirts. In order for the bookstore to have $6,660 in revenue for the fall semester, how many t-shirts must be sold if 150 sweatshirts are sold? Now in reality, if this was the only situation you had, you would simply substitute those values in and solve from there, and you should end up with 224 t-shirts. I would challenge you to take that equation that you first started with, R equals 15t plus 22s, and solve that equation for t, and then substitute the values in, and you should still end up with 224 t-shirts. That's the short video. So again, if you had any questions, if you wanted some more examples, please again refer to that longer video, or simply do the rest of the problems in your note packet and come to class with questions. See you then.